Describe the functions of the four components of a servo robot axis. There are four components of a robot axis: servo motor, encoder, mechanical structure, and home position sensor. A servo motor is an electrical motor that is connected by its shaft to the robot's mechanical structure. Servo motors are specially designed to be able to move their shaft at a specific speed and stop at a precise position under the control of the drives and robot controller. The encoder is an electronic device attached to the shaft of the servo motor. The encoder allows the robot controller to continuously monitor the position of the servo motors. It does this by sending a string of electrical pulses as its shaft position is moved by the movement of the motor. The pulses are counted by the controller to determine exactly where to stop the motor. The mechanical structure includes the gears, chains, and bearings, as well as the physical structure itself. The mechanical structure houses the other components and contains the parts necessary to complete the robot's required tasks. Home position sensors are used to reset the encoder value stored in the robot controller whenever the robot is homed. This is important because the controller uses the position where the encoder values are zeroed as a reference when it moves the robot. Describe the function of the homing procedure. Homing, or nesting, is an automatic procedure that causes the robot's axes to move to a position where they actuate their home sensor. The controller then resets its memory for each encoder position to 0. This makes sure that the robot will accurately go to each position stored in memory. The robot should always be homed when first turned on before it is operated or programmed. Describe the operation of the homing procedure for a servo robot. The homing procedure for a servo robot homes each axis in a specific sequence that ensures the robot will not crash into anything. Once the robot moves an axis until it has actuated its home sensor, the robot stops moving that axis and proceeds to the next axis in the homing procedure sequence. The time a homing procedure takes varies with the distance each axis is away from its home position sensor. For example, a robot may perform the following homing sequence. 1. Shoulder. 2. Elbow. 3. Wrist roll. 4. Wrist pitch. 5. Waist. Moving the shoulder axis first helps to ensure that the end effector is clear of any obstructions. The waist axis is usually homed last because it could crash the end effector into an obstruction if the end effector was not already in its home position. The robot controller will continue moving the axis until it reaches the home position. This procedure will continue until all axes are in the home position.